everyone. Good afternoon. Just quick introduction. We're here to test your knowledge on the SAT program. So everybody brought a number 2 pencil. No, I'm kidding. Shouldn't have to tell you that I'm kidding. My name's Brady Cline. I lead up Esri's advanced analytics, enterprise analytics, and AI. It's a practice that I joined Esri with 6 years ago. Give you a little bit of my background, just it gives me some credence of why I'm here and why I talk. Prior to that, I was the chief revenue officer for a startup doing computer vision problems for not just the national intelligence, but also for hedge funds. So I got to work with 2 of the most evil people in the world. But I got to do a lot of fun and interesting things with that. A little bit more on my data science background. I've been doing data science and AI since well before we called it data science or AI. We were calling it lessening cognitive burden in the field, mostly for military commanders so that they could make good decisions without really having to think about it, right? Always get some really fun lessons learned. You get really great little sound bites, like the moment that the plan goes to hell in a handbasket is the moment that all of the planning turns into the first bullet fired. I stop looking. I don't really think anymore. I operate, and that's why we do these trainings. And we still do the same thing today, right? Think of all the modeling that we do is all about training so that we're prepared to make decisions when all things are wrong and we need to make a good choice. A little bit about who Esri is. So while I talk about unlocking the power of location, Esri is the largest privately held location intelligence company in the world. I'd say that we're probably the largest geospatial intelligence company in the world. If you're not familiar with what GIS is, it's maps. Maps power everything that we do. Everything that we touch and operate with happens in space and time. So this gives us that ability to model that, interpret that, and then I'm going to throw this really awesome buzzword that people love to use, which is called digital twins. I hate saying digital twin because I work for a GIS company. Everything we've done is a digital twin, right? We represent the physical world in a digital sense. We've been supporting about 350,000 different agencies and groups, so whether that's commercial or federal or international, aid organizations, USDA, the list goes on and on of all the organizations and companies that we've supported along the 50-year career of Esri, a little over, it's almost 55 at this point. So I was doing an insurance presentation when I started doing this deck, so there's this little clip that seems out of place, which is the top 10 insurers all use Esri technology. It's a pretty good statement, and then obviously over the last 2 weeks, insurance becomes a very big topic, so you talk about it a lot, and you reuse slides. The other piece of that is 80% of the Fortune 100 are all using Esri capabilities and tools and technology in some way, shape, or form to solve hundreds of different problems across the globe. So I really do like to point out to this one little snippet from Fast Company. Esri's data-rich maps are the secret weapon behind many of today's most successful brands. So it's interesting because when I start and I come and I talk, I'm like the anti-map guy. So I work for a GIS company, we do maps, it's beautiful visualization, it's great. But what about all the problems that we have within our organization that we don't necessarily represent into a map, but we still need to do that analysis? That's what I like to bring to the table and get people to think about. It does work, I promise. So a little bit more on the markets and businesses. It's an eye chart, I get it. But really to take it away, kind of landing on what I was saying, it's business, it's utilities, it's power companies, it's natural resources, it's government. In all of these other areas that we're supporting and bringing spatial into the analytical process. So supply chain, risk management, corporate security, finance, public works, public health, logistics operations. I'm sure many of you in the audience have one of those problems that you're solving, and you may not actually be using spatial or location intelligence to the maximum capability. So what it really comes down to is, what are these location tools? What are they for? What are the business problems that they address? It's things like, where else can I find a customer like this one? So we could call that customer 360. We have different ways of rendering that question internal to our organization. Where should I open my next storefront, my physical storefront? How does that physical storefront interact with my digital storefront? Does one deter from the other? If I have a physical store, does that mean that I lose money on my digital store? Or does it mean quite the opposite? I think there's been several examples where we've actually seen the opposite. As we open a physical storefront, our digital orders increase, which seems counterintuitive, but if you think through it, it's the human feeling of feeling connected to the store, so if you have a problem, you can go back to them. What property should I buy? So this real estate question. Think of the expandingness of your business, whether it's, we'll pick a fast food chain in the franchising problem. What are they really? They're really real estate companies that are looking for new storefronts, new locations for them to go. But they need to understand not just the point of that parcel that they would go off and go buy, but they need to understand what's the context of everything around that. And again, we're solving those problems with us. I can give you a great example of what's the climate risk of land holding. So how do you bring in that representation of all of those risk factors into a spatial mean and start searching the globe, not an individual area, for what that is that you're looking to go do? I drink a lot of water, so I'll stop for a second while we read and really point out that, okay, we've labeled out all these questions that we can start answering, or we're asking ourselves internally. What are the technical challenges for those? So this is a little bit more technical of a slide, and I try to break it down because at the end of the day, I'm a sales guy, right? You saw the slide, I'm the sales manager. I'm kind of like the opposite sales guy. So it's, how do I make sense of trillions of points? So we've already talked about this real estate story. But what about, say, I have a logistics organization, and I have to get packages from one point to the other overnight, and I have all of these other factors that are into this, right? There's trillions of points that factor into that. Those points also become polygons, and then we started getting into these more complex geometries, and those are much harder questions to ask. Tools to answer those questions are harder to find. So that math, although seemingly it's just math, everything is just math, but we give you those tools to answer those questions. So how can we bring locations access to within my data lake? So how do I bring location intelligence and location analytics into a data lake or into my analytics platform? So I'll use something like Databricks. I need a way to bring spatial joins and connections into something like Databricks, and they just don't have the tools inherently. So we bring some of those tools to that party so that you can start making those spatial joins and connections. Why would you want to do this? Well, we were just talking about trillions of points. How long would it take you to run on your standard desktop trillions of points connected to billions of other points? Ultimately, you just give up. That's why we have cloud compute. That's why we have scalable computing. But most organizations don't have data scientists that have the tools to answer those questions in a form factor that the data science team is used to. We're used to like giving you a GIS professional, and that GIS professional takes a subset of your data, which we usually will subset out, have a human say, this is the area that I actually want to go look at. We break it down to a smaller piece, and then we break down, we eat the elephant, right? Piece by piece, meal by meal, we get to the answer. What happens when I throw all of the data at the question? We start getting a much more richer view of what those things are. So at the end of the day, it's really this business-focused system that we're bringing to the table so that you can look at your risk and resiliency, your logistics data throughout the organization. Obviously, this is a salesy slide, right? But the real takeaway should be, it's how everything fits together as an enterprise. It's not just that single answer that or a point solution. It's how location fits across the enterprise, powering all of your platforms, all of your analytical workflows. So what do I mean about powering these workflows? So it's these many different lenses of analytics. From the data engineering, and whether that's geocoding and geo-enrichment, and I'll just go ahead and ask, when I say geo-enrichment, do you guys know what that means? Okay, so I have, let's just pick 123 Main Street. That's an item in my database that I know I have a customer that lives there. How do I enrich all of, say, I'm a power company. How do I enrich all of the data within my platforms, all of my platforms, with that address? Well, I can make a lookup and say, okay, everybody that's at that address, but I gave it a really weird address. I gave it 123 Main Street. What's the typical, anybody that's worked with data knows that if I'm gonna go throw a fake address in, it's probably that one. So we do geo-enrichment. So we enrich all of that data with those points. And that first part there, the geocoding piece, I give that location a point. That way I can give myself a little bit of that entity resolution that's necessary for that customer. I can do other entity resolutions around geographies. Like we like to believe that we'll use a zip code as our area for a customer, and this is how we look at all of our customer data is based off the zip code. Is that a good way? Is that a good way for me to identify the tapestry of my customers is their zip code? Well, no, because I have multiple different types of dwellings within that zip code, and I've all of a sudden created this generalization because that was the easiest way that I could do it, because it's something that I can throw in a database and I can interpret. This gives us a way to do that, and the big data analytics side of that gives me more tools to do that at scale. So now I'm doing it with all of my customer data, not just subsets. I'm not gonna do it town by town or zip code by zip code. I can make new things. I'll claim this. My wife hates it, so let's go with it. My wife's a tax accountant. Special tax zones. So if you're a online retailer, and I get to do this because she's one of the experts on the Wayfair Act, and I'll assume nobody knows what that is. That is the beautiful thing that happened with the US government that said, anytime you sell something online, you have to collect sales tax on it. Yeah, she's one of the experts on that. It's her fault. But what that means is sometimes there's these special tax zones. That means I need to collect all of the sales tax that's responsible for that area. I live in a weird area where I have a special tax zone that is not determined by zip code. It's literally determined by a physical boundary. I live in Washington, D.C., out in the Virginia suburbs. We had the metro rail come out to us, so we have a special tax zone. Anything within like 3 miles of the metro has to pay a supplemental sales tax. It's great. Guess where nobody wants to go buy things. But with that, I've created this new question of how do I spatialize this new area that is, quote unquote, 3 miles from the metro rail? It offers new questions that I want to answer to, which are, is that 3 miles walking? Or is that 3 miles, as the crow flies, right, Euclidean distance? Or is that a driving distance? Because those are different. Define where the rail is, and I have a much different view of what that is. So as we move forward and we start looking through the technology piece of that, clearly what I just walked us through, that simple little scenario, is a much more advanced style of analytics than most organizations are ready to do today. So the other piece of that really very near and dear to my heart is GeoAI. What do I mean by GeoAI? That is any artificial intelligence that uses geography to answer the question. ChatGPT jumped onto the scene. We all got really excited. All of a sudden, AI, we've made it. We're all going to be professionals in AI. And then I asked it a really silly question. Hey, I got this point. I already defined. I used to work in intelligence. I got this point. Tell me more. That point is Arlington, Virginia. Okay. And that's really all it got. It gave me all the demographics. It basically gave me the Wikipedia results for that. Awesome. However, that point was dead center of the courtyard at the Pentagon. There's a lot more information that I have to collect around that. And there's a lot of focused information around that. So I've created new context for that point. Things that I couldn't do with a ChatGPT because it doesn't understand, like it doesn't understand math. I think we've heard those stories. It doesn't understand geography. So GeoAI is enabling that geography AI. I always stop at this user experience piece, and I've had a few conversations already today, that visualization is this thing that most of us hear and are like, yeah, that's the easy part. I'm coming from a company that does maps. What's the best visualization of showing things and where they're at? It's on a map. However, as much as we discount visualization, visualization is how all of our leaders, our executives, make a decision. Every single one of those decisions, they do not understand the analytics that went into getting to that visualization. That visualization has to represent action and what we're going to go do. Modeling and scripting comes along for the ride. You have to be able to model and script your data so that you can get greater insights. And then the last part is this sharing and collaboration. What good is your data if it is stuck in a silo, right? We've been breaking down silos left and right, and then we started creating new silos because I can't let everybody have that data. So it's about building that platform for sharing and collaboration. Again, these are all things that Esri does from the beginning for the last 50 years to ensure that location was a part of the analytical workflow. And now we have the tools today to really do that. So of the tools, and I'm going to talk about them really quick because I talk really long, and I've got like a 6-minute video that I'm going to play, so I don't have to talk. The things that we really kind of are pushing here and what we're talking about, GeoAnalytics Engine, which is a Spark native tool for bringing spatial analytics into your Spark environment. So you can do that spatial analytics at scale. Decision support tools, so back to your visualization. It's about being able to build those spatial results into a shareable dashboard, something that can easily convey the information that all of us have gone and analyzed. And the last one would be business analysts. So for us, we have not just this tool for doing business analysis, but also the data and tapestry information that comes underneath of it. So again, creating a much better understanding of those environments. So now I'm going to play this little video, and you won't have to listen to me talk anymore. Hopefully it's going to play.
Hello, my name is Dennis Gerard. I wanted to do a quick overview of GeoAnalytics Engine and how easy it is to use it within your existing Spark environments to bring spatial functions and spatial tools into your workflows. Now, to guide our discussion today, I have a simple notebook that's going to showcase some of these ideas. Now, in my case, I had an existing scenario that I needed to work with. I have several different sets of parquet tables. One set represents customer data, the other store data. Now, ultimately, what I need to be able to do is to geo-enable both of those data sets, measure the distance between each customer and the store that they transacted at, and ultimately aggregate that data to H3. So there's a number of different spatial functions that we need to be able to use to perform that entire process. Now, just to help guide the perspective around the scenario itself, here are some visual examples. So there's a customer data set. We have some sales attributes that we want to be able to use. We also have latitude and longitude that represent the customer's home location. Now, at the end of the day, we need to be able to measure the distance between the customer and the store they transacted at. And that store data exists in a separate data set, which you see here. We have the store's location and some additional information about the store. Now, at the end of the day, what we ultimately need to do is join this store data to the customer data and then work with the different location attributes to derive distances and then to perform aggregations. Now, just to summarize, what we're going to be doing is we're going to be reading over 19 million records from the customer data set. We're going to join location information from a separate data set that represents the store location. We're going to create geometry columns, do some reprojections, calculate distances, and ultimately aggregate all of the data to H3 bins to help us with visualization. Now, because our GeoAnalytics engine works within a Spark context, you obviously have a number of ways you might want to visualize the outcomes. Those might be in notebook visualizations, like a map that you see here. We might want to export those geometries into an open format like GeoJSON so that we can use them in other contexts. We could put them into different cloud storage systems like S3 or data warehouses or lakehouses. Or something that's also unique to GeoAnalytics engine is the ability to push the information into ArcGIS contexts. So if you have an existing ArcGIS Enterprise or ArcGIS Online setup, you can push the information into those contexts so that you can build meaningful visualizations and dashboards like you see here. Now, just to show how easy it is to actually work with this data, I'll run this box here. All we did was read Parquet files from the customer and store locations. And then as you can see here, using engine is quite simple. You don't have to change a whole lot of your code at all, actually. All you've got to do is incorporate the individual functions to enable geometry, do transformations, even measure distances, all within the context of your existing Spark data frames. And as you see in the resulting data frame, we now have geometry objects, and we've been able to calculate distances and even index the individual customer locations by bin ID. Now, just to show how fast all this works, I built a really simple interface in my notebook that allows me to slice and dice the inputs in different ways. So I can apply different brand filters, for example, specify how I want to visualize the information, or even adjust what level of aggregation that we want to use. Now, for example, if let's say I want to evaluate all of my customer records, I want to visualize the information by, say, total revenue, aggregate to H3 level 4, and I only want to evaluate customer records that are within, say, 100 miles of the store that they transacted at. I can click my button here, and in just a few seconds, it's going to perform the entire analysis. We're going to perform that join, get those distance calculations, and perform the aggregations to the H3 level that we specified. And now we have a visual of our data. And as you can see here, we chugged through 15 million records to aggregate that data to over 3,000 bins in just a couple of seconds. And at the end of the day, just to keep in mind, I'm not running this on some large Databricks Spark cluster. This is all just running locally on my machine. So just imagine how your own workflows might scale in, say, Databricks, EMR, or your favorite Spark environment. Now, as far as the outcomes themselves, we can take these outcomes, say a hex bin layer that we've generated here, and push them into an ArcGIS context where we might use it in a dashboard. And this dashboard actually shows how we were able to consolidate many different sources of data, including customer data, risk data, and also human movement data, and essentially create a scoring index that allows us to score in our locations in the national network against how well we predict they will perform based on their context. Or we could use something like a Power BI dashboard and do an individual store assessment where we can look at a single store, look at the customer distribution, and measure those threshold distances to capture the revenue associated with that store. At the end of the day, GeoAnalytics Engine is an extremely easy to use add-in within Spark that allows you to perform spatial operations, execute on spatial tools, and further enhance the analysis that you're performing with a spatial flair, and ultimately bring those to your decision makers. Thank you.
So that does it for me. I think if you have any questions, I'm certainly happy to take them. We have a booth over in the main area. Please stop by, have a chat. Any of us are happy to talk to you.